remember the exact moment everything shifted. 2 in the morning, university library, a single sentence stopped me cold. Everything we have ever seen, touched, or measured accounts for less than 5% of the universe. 5%. My hands shook. Every star photographed, every planet discovered, every galaxy mapped, all of it combined is essentially cosmic background noise. The universe wasn't lying. I simply hadn't been asking the right questions yet. A rounding error. A footnote in invisible ink. That night changed me forever. I realized something that would transform how I see everything. This mystery, dark matter, is not just physics. It is the most humbling, mind-expanding, beautiful puzzle humanity has ever faced. And if you're willing, I want to take you on my exact journey. Back in time through history, into the cosmos itself. Because understanding dark matter means understanding we are surrounded by an entire universe we cannot see. A universe that demands our wonder. In 1933, Swiss astronomer Fritz Zwicky studied the Coma cluster, hundreds of galaxies bound by gravity. Meticulous and brilliant, he grew increasingly confused. The galaxies moved so fast they should have exploded outward millions of years ago. Yet there it was, perfectly together, perfectly calm. The numbers made no sense. Physics offered no explanation. But the cluster remained, almost defiant in its stillness, a mystery demanding answers. Zwicky did something remarkable that night. Rather than doubt his measurements, he proposed something wild, a challenge to physics itself. There was additional mass in the cluster, he insisted. Invisible mass, mass exerting gravity, mass holding everything together. He called it Dunkelmaterei, dark matter. The scientific community laughed, shook their heads, and moved on. His radical idea vanished for decades, relegated to the margins of physics journals, dismissed as fantasy. But Zwicky had glimpsed something true. Something the universe was waiting to reveal. Then came Vera Rubin. Imagine being her in the 1900s, 60s, and 70s, a woman fighting for respect in a male-dominated field. While Zwicky's forgotten idea gathered dust, Rubin studied spiral galaxies with obsessive precision, measuring how fast stars orbit their centers. And here's where I need you to truly feel what she was seeing, because it shattered everything when I first understood it. Think about our solar system. Mercury screams around its orbit at nearly 48 kilometers per second. Neptune, in the freezing darkness of the outer reaches, crawls along at just 5 kilometers per second. The further from the center of gravity, the slower things move. It's elegant physics that Newton and Einstein both agreed on completely. The universe follows rules, and Vera Rubin expected galaxies to behave exactly the same way. Stars near the bright galactic center move fast. Stars at the dim, sparse edges move slow. Logical, obvious, settled science taught in universities for centuries. Vera Rubin expected galaxies to behave this way, the prediction all physics supported. Stars at the edges should slow down like Neptune. The pattern should repeat. The universe should make sense. And then she looked at her data. Stars at the far edges of galaxies moved just as fast as those near the center, sometimes faster. Rubin stared at her data like a magician's impossible trick, except this was real. These galaxies should have torn themselves apart, but they didn't. Something invisible, something massive, held them together. A halo of hidden matter surrounding each galaxy. Rubin had rediscovered Zwicky's ghost, dark matter. The universe refused to behave, and this time the evidence was undeniable. Not a single observation, not an outlier, but a pattern. Galaxy after galaxy, every single spiral galaxy she examined, displaying the same impossible behavior. The data was pristine. The measurements were precise and repeatable. The conclusion was unavoidable, inescapable. Something vast and invisible surrounded every galaxy, something we could not see, could not touch, yet could absolutely detect through its gravitational influence. Its invisible hand shaping the cosmos. Zwicky had been right all along. 40 years earlier, he had glimpsed the truth that the universe was keeping hidden. And now, Vera Rubin had brought that truth into the light, forcing us to reckon with the deepest mystery of all. I felt an almost physical ache learning this history. Here was science at its most heroic, not marching forward with false certainty, but admitting it was wrong. The universe is stranger, richer, more complicated than our brightest minds imagined. This is the opposite of dogma. This is humans staring at reality and saying, we don't understand, help us, teach us, show us what we're missing. And the universe, patient and mysterious, obliged. So what is dark matter exactly? And here is where I have to be honest with you in a way that I find genuinely thrilling and slightly terrifying. We don't know. Not really. Not yet. After decades of dedicated study, after billions of dollars poured into research, after some of the greatest minds alive dedicating their entire careers to solving this cosmic puzzle, the answer remains hidden from us. But that doesn't mean we're helpless or lost. We know what it does. We know its effects on galaxies and their rotation. We know its consequences rippling through the universe itself. We just don't know its true identity. And sometimes, in science, that's almost more interesting than having the answer. Dark matter exerts gravity. It pulls on visible matter, holding galaxies together like invisible hands clasping the cosmos. Its gravitational scaffolding shapes the universe's structure. Those vast cosmic webs of galaxy filaments and voids mirror neural networks and ancient root systems. Dark matter provided the framework upon which all visible matter gathered. Planets, stars, galaxies. You, me. Everything we call home emerged from this cosmic uncertainty. And that mystery invites us to wonder. 27% of the universe is dark matter. 68% is dark energy, mysteries we'll set aside. That leaves 5%, everything else, all galaxies ever mapped, all stars ever photographed, all planets, asteroids, comets, every black hole, every nebula, every atom in your body and mine, in everyone you've loved. 5%, 1/20th. A cosmic footnote to a story written almost entirely in darkness. What is dark matter? The question haunts the brightest minds. Physicists hunt WIMP, weakly interacting massive particles. Imagine mass, gravity, yet passing through ordinary matter like a ghost. Right now, trillions stream through your body, through Earth, through buildings and bones, completely indifferent, touching nothing, saying nothing, yet shaping everything we observe in the cosmos. Scientists have built extraordinary detectors, buried miles underground in the darkness, deep in abandoned gold mines, in mountain tunnels carved through ancient rock, places where the massive overburden of stone shields the equipment from every known radiation source in the universe. They cool the instruments to temperatures near absolute zero, reducing all thermal noise to a whisper. They isolate the detectors from vibrations, from the hum of the world above. They wait. They watch. Some of these experiments have been running for decades now, collecting data relentlessly, night after night, day after day, waiting for that single, rare moment when a dark matter particle might collide with an atom of ordinary matter and finally announce itself. And so far, the darkness keeps its secrets, but they keep trying. Because one day, one of these detectors might pick up that signal, and everything will change. WIMP are just one possibility. Other theories propose primordial black holes, microscopic singularities formed moments after the Big Bang, permeating the universe by the trillions. Or axions, ultralight particles originally proposed to solve a different physics problem, now considered potential dark matter. Or something we haven't imagined yet. Something exotic. Something that might require us to rethink gravity itself, to rewrite equations firm for a century. And that possibility, that we might be fundamentally wrong about something as basic as gravity, that is what makes dark matter not just a scientific mystery, but an invitation to wonder. And that possibility forces us to sit with uncertainty, to love questions more than answers, to stare into genuine darkness and feel wonder instead of fear. This isn't about particles or gravity anymore, it's about reality itself. Every time we think we've mapped the universe completely, we discover 95% remains blank. Unknown, waiting, that knowledge is humbling, terrifying, magnificent, and it's an invitation to wonder. I returned to that library chair recently, coffee growing cold in my hands, the way it always does when you're lost in thought. I thought of Vera Rubin, who spent her life mapping invisible things. Near the end, she hoped dark matter would remain mysterious enough to occupy scientists for generations. She got her wish. She died in 2016 without answers. Neither do we. Neither will our children, probably. The mystery persists, waiting for those bold enough to dedicate their lives to solving it. The universe is bigger than our equations, stranger than our theories, grander than our imaginations. It cannot be contained by human knowledge, and that is beautiful. Mystery will always exist. Wonder will always be possible. The cosmic frontier will never close. There will always be something left to discover, to explore, to be humbled by. That is the most profound thing I have learned. I felt that same dizzy, breathless wonder in the library. Years ago, those 5% shattered everything I thought I knew. But this time, I didn't fear it. I found it magnificent. We live in a universe far larger, stranger, more beautiful than we comprehend. That gap between what we know and what we don't, it's not failure. It's the future. It's where discovery lives. The cosmos still holds mysteries that keep humanity awake at night. If you want to explore them with me, to venture deeper into the questions that define us, join me next time. The universe is just getting started.